Today we will go over section 3.3, which is optimization problems. So previously, if you guys watched or did chapter 5, there was a section called optimization problems involving exponential functions. So we will be doing the same thing but more in depth. So let's start by a definition. Optimization means determining values of variables so that a function which represents quantities such as cost, area, etc. can be either minimized or maximized. So these can be applied to real life where your boss asks you to minimize the cost given the material, or calculate maximum efficiency for studying, maximum profit, things like that. And these problems will be given in the format of word problems. They're going to be called optimization problems. So we're trying to find the best possible outcome given the restrictions, which in this case would mostly be domain restrictions. From the previous section, we learned that we can also calculate maximum and minimum at endpoints, therefore from the restrictions given. A farmer has 800 meters of fencing and wishes to enclose a rectangular field. So okay, let's do it step by step. So I know that I have 800, that's about 8. So 800 meters of fence, and I'm dealing with a rectangular field. That's perfect. Okay. And one side of the field is against a country road that is already fenced. So I'm just going to put my road over here, and I'm going to say this is my road, and I know this is fenced already. So let me put it with a different color. So this is fenced, so I don't count that. So the farmer needs to fence only the remaining 3 sides of the field. The farmer wants to enclose the maximum possible area and to use all the fencing. How does the farmer determine the dimensions to achieve this goal? So from here, I need to make up a function because I don't have a function. In order to make this function, I can start, because it says maximum possible area, I can start with an area function. That's what I need to find. How do I do that area function? First, I can just give a variable for the width or length. So let's say I call my width x, and I know my widths are going to be equal to each other because it's a rectangular. I don't know my length. However, I can represent my length in a way that I know in total I have 800 meters of fence, right? And I know whatever is left for this length is going to be 800, the total fence, minus 2x used. Because that minus 2x represents how many fence I use for these two. And just take that out, whatever is left will be representing your length. So now my area function is going to be, how do I find the area of a rectangular in the first place? I multiply width by length. And I know my width is x, and my length is whatever I found up there, which is 800 minus 2x. So as a result, my area is going to be 800x minus 2x squared. So in previous problems, meaning the previous section, what we had was they already gave us the restriction, like domain restriction, before we even took the derivative of this. Right now, I can actually put the domain restriction myself because I know total I have 800 meters, right? And if I put the domain in terms of x, and let's say my x lowest it can be is 0 obviously, and the highest it can be, I'm thinking I have 2x over here. So I cannot say 800 because I have also the other x over here, which I have to use the fence. So I can literally divide it by 2 and just say the highest I can possibly get is 400. So now the first thing I do is finding the critical points by taking the derivative. So I know my function is right over here, which I'll be taking the derivative of. So if I take the derivative of the area, I will get over here, keep the constant, which is 800, and when you take the derivative of x, it will give you 1. And then I start by over here by applying the power rule. I will keep -2. I will bring the power of 2 in front, and I will keep my x, and when you do -1 to the power, you will just get 1. So as a result, my answer is 800 minus 4x. So now all I need to do is equal this to 0, which we did before whenever we had critical points, and I will send that 800 to the other side, which will give me -4x equaling to -100, and I will divide each side by -4, which will give me the x value of 200. So I found my critical point, and I know I can use my endpoints as well, and my second step is going to be plugging it back into my original equation, which I will be doing by erasing some of these. So now I know the first thing I'm going to do is plugging in 200. I know one of my endpoints is 0, so I will plug in 0. And I know my other endpoint is 400, so I will plug in 400 to this equation. So when I put that into my calculator and I get these values, I know when I look at the values and interpret it, these are not possible, because what we got right now is the maximum possible area. And it's not possible to get maximum possible area of 0, so it just doesn't make sense. So what I have as an answer is here. It means that my farmer, the maximum area he can enclose is 80,000 meters squared, and it's within a field of 200 meters, which represents my width. And if I plug it back into here, my 200 in the x spot, I will get the value of 400 meter for my length. So that would be my answer. So if the question was asking how he determines the dimension to achieve this goal, we determined the dimensions. So my width is 200, my length would be 400. So a piece of sheet of metal 60 centimeters by 30 centimeters is used to make a rectangular box with an open top. Okay, from here I know I'm dealing with a rectangular box, which I'll just draw something that representing with an open top. So if I have something like this, and I'm gonna represent that I have the bottom by just like filling it in, and I have the sides, but it's just I have an open top. And it wants me to determine the dimensions that will give the box with the largest volume. So I already know as a function what I'm gonna have, what I'm trying to find is the volume function. And how do I find the volume of a rectangular box? Well, I know that I'm gonna times height times width and length, and I know height is right over here, represented here. I'm gonna call this my length, and this is my width over here, right? And over here, thankfully, now I need to find what's my height, what's my width, and what's my length is, right? So I know we're cutting out these boxes right over here, so we can fold it. That's how we're gonna make the box, right? And they're telling us that each of these sides of these little boxes are called x. And I know that x corresponds to right over here where my h is. So I already know I'm gonna draw the x again. So I'm just gonna put the x, yeah. So I know my h is represented by x. So technically I can write that. Now I need to find my width, and I know my width, they already tell us that it's 30 centimeters. However, you cannot just put 30 centimeters because remember you're cutting this piece out and you're cutting this piece out. And I know how long these are. This represented by x and this is represented by x also. So I can say for my width, I can represent it by 30 minus 2x because I cut that 2x out. Same thing for the length. I see that they give us 60 centimeters. However, I do cut out this piece and this piece right over here, which both of them are in x length. And when you add them together, you're going to end up getting 2x. So I'm going to say 60 minus 2x is going to be my length. So now if I expand it, I'm going to get the function of 4x cubed minus 180x squared plus 1800x. So now, like before, I have my function. Before taking the derivative, I need a restriction for my domain so I can have the endpoints as well. So what can be my restriction? I know I'm going to start with putting the x obviously in the middle, right? And I'm going to say that it's going to be either from 0, my smallest value can be 0, bigger than 0, so it's not equal to, so don't put equal to, it cannot be just 0, but bigger than 0. My highest value, however, can be 15. Why? It's because if you look at my function over here, I cannot have 0 centimeters. I need at least 1 centimeter over here representing the width. And I know if I say my x, let's say 20, right? And if you put 20 for the x value, you're going to end up getting 30 minus 40, which is negative. That's not possible. So when you're doing it, you can just say, okay, 2x equaling to 0, right? And put that to the other side, negative 2x equaling to negative 30, divide by negative 2, I'm going to get x equaling to 15. So the highest value I can get for my width is 15. You could have started over here too, but you're going to get a higher value obviously. So you need to find the smallest value. So for this, let's do this for this again. And 60 minus 2x will equal to 0. Actually, when you're solving it, it's better to do a bigger sign. But just to see the value, you're going to get the same thing as soon as you don't put equal over here. So we do this again, send that 60 to other side, negative 2x equaling to negative 60, divide by negative 2, you're going to get x equals 30. So for this side, the highest value you can put for x is 30, but I have to consider the lowest value in order to restrict myself even further, because I cannot have 30 over here or else I'm going to get negative 30 as a result. So now I'm going to take the derivative. I'm going to start by putting the constant, apply power rule to the x cubed, so that means bring 3 to the front, and I'm left with x squared when I do minus 1 to the power. Same thing over here, I'm left with negative 180, apply power rule, bring 2 to the front, I'm left with 2x, and apply the same thing, so my constant stays the same. I know when I take the derivative of x to the power of 1, I'm just left with 1. So I'm just going to simplify this even further. I'm left with 12x squared minus 360x plus 1800. So I found my derivative. Now what do I do? Because I'm trying to find the critical points as my first step, I equal this to 0. I realize I can actually take out 12 from the function because it's a common number, and I will end up getting x squared minus 30x and plus 150 equaling to 0. Now I can actually simplify this by using the quadratic formula, right? It doesn't come out that easily, so I will be using quadratic formula right over here. So I'm going to say, remember what the quadratic formula is. So now when I plug it in, I get the value of 30 plus or minus root 300 over 2, which I can divide it by 2 to get 15 plus or minus, and I will take out 25. So this root is actually can be represented by 25 times. Sorry, let's take out, instead of 25, let's do 100 times 3, right? And this 100 can actually come out of the root as 10, so I have 10 root 3, and I'm dividing by 2 anyways, and I can only divide the outside, so I will end up getting 5 root 3 as an answer, and that will be one of my critical points. So now I put my x into 2 because it's plus or minus. So one version of the x is 15 plus 5 root cube, and the other version would be 15 minus 5 root cube, because we need to differentiate into positive and a negative version. So over here, if you put it into your calculator, you will end up getting a value of 23.7. And if you put this one into your calculator, you will get the value of 6.3. And these represent centimeters, right? Now the next thing we do is check my restrictions. My restriction is between 0 and 15 centimeters. So this one passes, this one is within my restriction, within my domain. However, this one is way higher than what my domain says, so we don't count this as one of my critical points. So now I know as one of my points I have 6.3 centimeters. And I put also my endpoint, which is 0, and I also put the other endpoint, which is 16 centimeters. Now all I need to do is plug these values to my volume function. So when I do that, I'm going to do V 6.3, V 0, and V 15. And if you put it into your calculator, you will get these values. Another thing you realize when you put the endpoints is even before you put it into your calculator, 0 centimeters is just not possible, right? So I'm just going to say 0 for this. Even if you plug it in, it's going to come to 0. So I know this is not it. 15, put this back into here, 15, and you will get a 0 centimeter of a width, which is not possible again. So my answer would be right over here. So largest value, I get it when my x is 6.3. So because it says determine the dimensions, that's what I'm going to do. So I'm going to plug it to my width and to my length. So I will get the dimensions of these. So height 6.3, width my 17.4, and length is going to be 47.4 centimeters. So those would be your answer. So Ian and Ada are both training for a marathon. Ian's house is located 20 kilometers north of Ada's house. So I'll start by drawing again. So let me say this is Ada's house, and Ian's house is located 20 kilometers to the north. So here is my 20 kilometers, right? At 9 a.m. one Saturday, Ian leaves his house and jogs south at 8 kilometers per hour. So I'm gonna say this is my Ian, right? And it's what, 9 a.m.? So 9 a.m. he leaves, and I can say his velocity is 8 kilometers per hour, right? At the same time, Ada leaves her house and jogs east at 6 kilometers per hour. So Ian is coming this way. I'm gonna represent Ada with green. So this is my Ada, but she goes to east, right? So she goes this way, and her velocity is 6 kilometers per hour. When are Ian and Ada closest together, given that they both run for 2.5 hours? So I know they go for 2.5 hours, so we'll solve it from there. So I'll start by giving a function for each of these people. So I'll start with Ian, which is the easiest, to be honest. So I know Ian starts at this point right over here, which I'm going to call I, right? And he goes up until probably A, so I'll just call I to A. So to get that function out of the way, I know that he needs to go for 20 kilometers, right? I'm gonna say minus, because he decreases that distance because he's walking towards Ada, and he goes by 8 kilometers per hour, which means by each time represented by hours, he's decreasing the kilometers by 8. So I can say 8t over here, so 20 minus 8t. Same thing for Ada. However, I don't know how many kilometers she goes, so I'm just gonna call the point she goes to. Let me just put it different. So the point, this point, she goes to, let me call it J, right? So AJ, I'm gonna call it A to J. I know she goes for 6 kilometers per hour, so I can just say it's 6t, right? So since that I know they're apart in this distance, I can find the distance between them by representing it by st, because s represents the position and t is my hours, by finding the value of this, which from Pythagorean theorem, if you realize, is I can first start with the IA position, which is right here, and square it, plus, and then start with A to J position, which is right here, so that's 60 squared. And from here, I can actually get the values of still in the root. So I'm going to expand that to get 100 t squared minus 320t plus 400. And I can rewrite it if needed to the power of 1 over 2, because I know I'm going to take the derivative of this. So to make it easier to take the derivative of, I'm going to put the same thing and do the power of 1 over 2. So now from here, since I have my function, all I need to do is take the derivative again, find the critical points. So if I take the derivative, I start from the outside first. So starting from the outside, meaning I'm going to count this as a gx right over here, which means I'm going to start by applying the power rule, bring 1 over 2 to the front, keep gx the same, so I have 100t squared minus 320t plus 400, and I do minus 1 to my power, which will give me negative 1 over 2. Now I take the derivative of gx and multiply by it. If I take the derivative of 100t squared, keep 100 the same, apply power rule, so bringing that 2 to the front will give me 2t, and I do minus 1 to the power, so I'm left with 1. The second part, I keep the constant, and I realize I only have a t, which is going to become 1. The constant will just become 0. Anything constant when I take the derivative will be 0. Now I can simplify this even further. I know for this part, I'm going to get 200t minus 320, and I'm going to divide that by 2 to put them together. So my derivative ended up being 100t minus 160 and 100t squared minus 320t plus 400 to the power of negative 1 over 2. So now that I have my derivative, all I need to do is equaling this to 0. And if I multiply this by the denominator for both sides, I'm going to get rid of the denominator. So I'm left with 100t minus 160 equaling to 0. Now I'm going to send 160 to the other side to end up with 100t equaling to 160. Now I'm going to divide it by 100 both sides, so I ended up with 1.6. So now that it says, given that they both run for 2.5 hours, I can actually put a domain for this. So I can say starting from 0 hours, my maximum hour would be 2.5 hours, because that's how long they run. They stop running at 2.5 hours. Now all I need to do is plug in these values to my original equation. So now, because this was my original equation that I found, when I plug in 1.60 and 2.5, I get these values, and I see that it's asking for the minimum value, right? How do I know that? Once ion and eta closes together. Closes meaning whatever the distance is smaller, smaller meaning minimum value. When I look at these values, I have 12, 20, and 15, and I know the 12 is the lowest value. Therefore, it's at 1.6 hours that they are closest together. So the minimum value is 12 kilometers. and add, since they give us the 9 a.m. and it's asking for when, I can technically convert this 1.6 to an hour. So 1.6 represents 1 hour and 36 minutes when you convert it. So I'm going to add that to my 9 a.m. because they start from 9 a.m. 1.6 represents after. So 0 represents my 9 a.m. So if I add that, I'm going to get 10:36 a.m. is when they are closest together. So if you have any other questions that you want us to solve and send it to you, you can always go to our website and go to our forum section where you can ask any of your problems regarding this course or even any other course that we offer.